go. So, try to draw a dot diagram of this compound, ASI3. Actually, want me to work through it first? Okay, first thing I do, I add up valence electrons. Go to the periodic table. Arsenic. Now you could do the 1s2, 2s2, 2p3, all that stuff. Don't mess with it. Just go down and dirty valence electrons. Arsenic is going to have 5. Iodine has 7. The formula gives me 3 iodides, so it's 3 times 7. So it's going to be 5 plus 21. I am going to have 26 electrons to fiddle with. Now, second step, make a skeleton structure taking the clue that the central atom usually, and this is chemistry so there aren't ever hard fast rules, but usually the central atom is written first. Now, that means I would make a skeleton structure with arsenic, and then I'd go iodide, iodide, and iodide. Now there's a couple assumptions that I just made. It's too bad that's kind of on the low side. But the first assumption is this. Halogens, change color. Halogens, there's an L there. Halogens terminate a chain in a molecule, okay? So what that means is iodine's a halogen, so it's only going to have one bond to it. So it has one bond. You'll watch that tonight, okay? So halogens terminate a chain. The other one that is always going to terminate a chain is hydrogen. And the reason why hydrogen does is because if you look at the periodic table and look at hydrogen's 1s1 configuration, yeah. Well, just sort of a chain, how I'm kind of like drawing these molecules out. That's what I kind of mean by, one after another after another. Iodine is always, a halogen is always going to be at the end. Of whatever is there, it's going to be at some end. Yeah, so that means they only have one bond. And hydrogen does the same thing. Hydrogen's reason is a little different because hydrogen's noble gas configuration is helium. Helium has 2 electrons. The most hydrogen can have around it is 2 electrons, meaning one bond. Hydrogen doesn't have enough protons to hold any more than that, and it doesn't. Hydrogen doesn't have a p sublevel. It couldn't put any more electrons around a hydrogen if you wanted to, because it only has one puny little skinny proton in there. Max electrons I can hold around it are 2. Yeah.
Does it matter?
Nope. Not yet. No. So now I'm looking at this, and once I get a skeleton diagram, I'm going to count up those bonds. 1, 2, 3, realizing each bond represents 2 electrons, making 6. Subtract that from my total, leaving me 20 electrons left over. Okay? And these are the ones that I am then going to go around and place to ensure that everybody gets 8. Alright? So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Where do the last 2 go? Yep, 19, 20. Okay? By doing that, everybody here has 8 electrons around it. And what's crazy about that, that is the shape of that molecule. Yeah. Yep. 2 electrons. Each bond counts for 2. Okay? So I just did that one. So, yeah. But that's, I'll talk about that. There's some tricks on the double bond. Now, I want so count valence electrons. Yeah, that'd be weird. We're going to keep drawing pretty simple ones initially. Here goes. Give everybody a minute more. Still working? A couple working still? What? What did he say? What did you call me?
He said I get it because I watched the video.
I think he called me.
Yeah.
Okay? So here, I'm going to do this one. So first thing I want to do, valence electrons. If I look at silicon, I go straight up. I got 4 for the silicon. I have 4 chlorines. That little subscript means 4. And chlorine happens to be 7. So it's going to be 28. So the whole darn thing's going to add up to 32 electrons. Taking the clue that the first atom in a formula goes in the center. Also the fact that chlorine is a halogen, so it's going to be at the end of something. I am forced, because I don't have any other choices, to start off with a structure looking like that. I then come back and I count up the bonds. 1, 2, 3, 4. Multiply that by 2. Makes 8, so I subtract that from my total. So now I got 22 or 24 leftovers. Left. Here they go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right? Everybody's got 8. I got 8 through there. 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 And I have 8 through there. All right? Draw SEH2. You guys, if I'm going to do this one, you should have gotten selenium has 6 plus 2 times 1 for the hydrogen. So I'm going to get 8 total. The fundamental basic shape is going to look like this. Hydrogen is happy, has a noble gas structure with 2 right there. So 2, 4 coming off of that. I get 4 left over, and I put 1 there, 1 there, 1 there, and 1 there. And now everybody's happy. Yeah, Britt? Nope, you could have done this up here and over there and put it like that, and it would have been the same thing. And that's going to be kind of the next installment later on, is trying to make a structure out of these things. Okay, I'm going to give you another one.